Good day, doctor. My name is Ong Zi Eng. My matric number is 233000780. I am from Monday section group 8A and my lab partner is Sophia. In part A of the experiment, the objective were to determine the projector range as a function of inclination angle, to determine the maximum height of projection as a function of projection angle, and to estimate the value of the gravitational acceleration of the Earth. First of all, I set out the ballistic unit, recording strip, and a meter scale. Then I placed a steel ball on the trigger of the ballistic launcher and adjusted the projection angle at 25 degrees. The firing was pulled to the first tension stage, which corresponds to the first initial velocity, and the ball was launched. After firing, I measured and record the horizontal distance between the trigger and the midpoint between the light barriers. I also measure the horizontal range and maximum height of projection for this launch. I calculate the actual initial velocity of the steel ball using the data obtained. The same procedure was repeated for projection angle of 35 degree, 45 degree, 55 degree, and 65 degree, still using the first tension stage. For each angle, the range and height were recorded. Next, I repeat the experiment using the second and third tension stage, representing second and third initial velocity. In part B of the experiment, the aim was to determine the maximum projectile range as a function of initial speed. As in previous trials, I began by placing the steel ball on the trigger of the ballistic launcher and set the angle of projection to 45 degrees. Then I pull the firing string to the first tension stage, corresponding to the first initial velocity. I calculate the actual initial velocity using the measure distance and known parameters. After that, I find the steel ball and measure the range. The experiment was then repeated using the second and third tension stage, which corresponding to second and third initial velocity. For the first question, in my opinion, the best angle to start the experiment is 45 degrees. This is because no air resistance and same initial speed at a projectile launch at 45 degrees achieves the maximum horizontal range. Starting at this angle provides a good reference point for comparing how changes in angle affects range and height. Next, a way to accurately measure the height of projection of the steel ball in this experiment is by using a marked vertical scale placed behind the point of launch and recording the motion using a high-speed camera. The frame where the ball reaches the highest point can be analyzed to determine the maximum height. Moreover, a way to determine the time taken for the projectile in this experiment to reach the maximum height is by using a stopwatch to record the launch and instant the ball reaches its highest point. Also, half of the total time of flight, if the launch and landing heights are the same, also gives the time to reach the maximum height. For question number 4, in my opinion, the type of material of the ball does not affect the range and height of projection. In ideal projectile motion, only the initial velocity, angle of projection, and gravitational acceleration matter. The mass and material of the projectile cancel out in the equations of motion. For the last question, in real-world experiments, air resistance and shape difference introduce discrepancies. A wooden ball being lighter or often larger is more affected by air drag, causing it to reach lower heights and shorter range than a denser steel ball, which better maintains its velocity due to its mass and smaller drag coefficient. Even slight difference in surface texture can impact how air flows around the object. That's all for me. Thank you.